This morning, you made a choice you don't even remember making. Maybe you left 5 minutes late. Maybe you took a different road. Maybe you said yes to a coffee you almost skipped. It felt like nothing. But the real answer is far stranger. That tiny, forgettable moment might already be rewriting the next 20 years of your life. You've probably heard the phrase before. A butterfly flaps its wings in Brazil, and somewhere on the other side of the planet, a tornado forms in Texas. It sounds like a poetic exaggeration. It isn't. It's a real scientific discovery, and it didn't come from a poet. It came from a meteorologist who was just trying to predict the weather. His name was Edward Lorenz. In 1961, he was running a computer weather simulation at MIT, testing patterns over and over to look for trends. One day, he wanted to rerun a sequence he'd already done. To save time, he typed in a number from partway through the previous printout instead of starting from scratch. The number was 0.506127. He typed 0.506. He rounded it, a difference smaller than 0.001%. He expected the same weather pattern to appear again. It didn't. Within a few simulated months, the new pattern looked nothing like the old one. Same equations, same starting point almost. A near-invisible rounding error had completely rewritten the outcome. Lorenz didn't dismiss it as a glitch. He sat with it. And what he realized would eventually change physics, biology, economics, and the way you understand your own life. He called it sensitive dependence on initial conditions. You know it as the butterfly effect. The idea is simple to say and almost impossible to fully accept. In certain systems, the tiniest possible difference at the start can lead to a completely different outcome later. Not a slightly different outcome, a completely different one. And weather, it turns out, is exactly that kind of system. So is your heartbeat. So is the stock market. So, quite possibly, is you. Here's where it gets uncomfortable. Most of us like to believe our lives run on big decisions. The job we accepted, the person we married, the city we moved to. We tell our life story like a highlight reel of major turning points, each one clearly labeled, each one deliberate. But chaos theory suggests something almost insulting to that story. It suggests the real turning points were often invisible. A missed train, a song that came on the radio, a stranger who sat down next to you because every other seat was taken. Think about it for a second. Could you trace, right now, the exact chain of tiny accidents that led you to the job you have, the friends you have, even the person you're closest to? Most people can't. Not because the chain doesn't exist, but because it was never designed to be traceable. It only becomes visible looking backward, and even then, only partly. This isn't just a nice metaphor. It's baked into the mathematics of how certain systems behave. In the 1970s, mathematician Benoit Mandelbrot expanded on this idea while studying what looked, at first, like a boring technical question. He wanted to know how long the coastline of Britain actually was. The answer, it turned out, depended entirely on how closely you looked. Zoom out, and the coastline looks like a smooth curve. Zoom in, and it explodes into jagged inlets and coves that were invisible before. Zoom in again, and you find more detail nested inside that detail. Mandelbrot called shapes like this fractals, patterns that repeat at every scale, revealing more complexity the closer you examine them. Why does a coastline matter to your life? Because Mandelbrot showed that many real systems don't behave in tidy straight lines. They behave like coastlines. Complex up close, deceptively simple from far away. Your life, viewed as a straight timeline of major events, is the zoomed-out version. But zoom in, and you find thousands of tiny forks in the road you never consciously noticed you were standing at. There's a reason this idea took root far beyond meteorology. In 1963, Lorenz published a paper with a title almost nobody outside of academia ever reads: Deterministic Non-Periodic Flow. Buried inside were the equations that would later be visualized as a strange looping shape scientists now call the Lorenz attractor. A kind of infinite figure eight the system traces without ever repeating exactly. It looks chaotic, but it isn't random. That's the part that should genuinely unsettle you. Chaos, in this scientific sense, doesn't mean random. It means unpredictable, while still following exact rules. Your life may work the same way. Not random, not directionless, but so sensitive to small conditions that predicting its exact shape from the outside, even with perfect knowledge of the rules, is functionally impossible. You are not being steered by fate. You're also not adrift in randomness. You're something stranger. A deterministic system so complex that its own outcome can't be known in advance, not even to you. Here's the twist most people miss when they first hear about the butterfly effect. They assume it means small things don't matter, because the outcome feels so far removed from the cause. It's actually the opposite. It means small things are the only things that ever mattered. The big, dramatic decisions you agonize over, statistically, you can often see them coming. You weigh the options. You brace for the consequences. It's the moment you weren't paying attention to at all that quietly bends the entire trajectory. Psychologists have found something eerily similar happening inside human memory and decision-making. Research led by Daniel Kahneman, particularly his work on cognitive bias with Amos Tversky, showed that people consistently misjudge which moments actually shape their choices. We overweight dramatic events. We underweight the small, repeated, almost invisible ones. A single argument feels like the reason a relationship ended, but often it was hundreds of tiny, forgettable interactions that quietly set the conditions for that argument to matter as much as it did. This is where the science stops being abstract and starts feeling personal. If a rounding error the size of 0.001% could rewrite a weather simulation, what does that mean for the tiny choices sitting in front of you right now? The text you didn't send, the class you almost skipped, the 5 minutes you spent talking to someone at a party you almost didn't attend. None of it feels significant in the moment. That's exactly the point. Significance in a chaotic system isn't something you can feel in real time. It only reveals itself in hindsight, and often not even then, because most of the branching paths you didn't take are invisible to you forever. You'll never know what your life would have looked like if you typed 0.506127 instead of 0.506. Some scientists have pushed back on how far this idea should be stretched. Complexity researchers point out that not every system is equally chaotic. Some parts of your life really are stable and predictable, buffered against small disruptions by habit, structure, and repetition. The butterfly effect doesn't mean everything is fragile all the time. It means certain moments at certain thresholds carry disproportionate weight, and you rarely know which moments those are until much later, if ever. So what do you do with that? You can't live paralyzed by the idea that every sip of coffee might be secretly reshaping your future. That's not the lesson here. The lesson is quieter than that. It's permission, almost, to stop believing your life is only built from the moments that felt big. To notice that the version of you sitting here right now, reading this sentence, was assembled from thousands of decisions so small you've already forgotten most of them, and a few of them, without ever announcing themselves, changed everything. Tonight, when you go to bed, you won't remember most of today. Tomorrow, you'll make another quiet decision you won't think twice about. A road taken, a word said, a moment paused. It will feel like nothing, but the real answer is far stranger. It might be the only thing that ever really mattered.